Automobile body consists of large number of stamped sheet metals welded together by resistant spot welding. Average automobile has between 4,500 to 6,500 welds to join the body together. The quality of welds determines the integrity and crushworthiness of the car body. Among all manufacturing processes, welding is the only one that have no effective real-time quality assurance program. On an automobile assembly line, one or two car bodies are pulled off the production line at the end of the shift and torn apart weld by weld to examine the weld quality by using the chisel method. The costs associated with this type of weld inspection are enormous. In addition, it is labor intensive and time consuming. By the time a welding problem is identified, hundreds or even thousands of cars may have already left the assembly plant. If the welds on this disassembled car meets all the specifications, then all the cars made on that line that day are deemed to have good welds. Logically, this clearly doesn't make any sense because the welds that were inspected never left the plant and the welds left the plant were never inspected. In Europe, the situation is even worse. Current industrial monitoring systems check the quality of the nugget after processing 15 cars once every 2 weeks. The nuggets are examined off the line using destructive process, which is taken approximately 10 days to complete, causing a long delay in the production process. The main quality control tests are still the destructive chisel test and the peel test, which are carried out on the welds obtained from the production line of the product. What is expulsion? If excessive heat is applied or applied too quickly to a weld, the metal in the fairing surface will be completely melted. The molten metal is expelled to the air under high pressure. When the molten metal meets the air, a burst of bright light is emitted. It is called expulsion. Expulsion at the fairing surface is highly undesirable in terms of weld quality because the expulsion involves loss of liquid metal from the nugget during the welding. Expulsion weld is always weaker in strength and smaller in diameter than non-expulsion weld. Expulsion weld uses 3 to 4 times of the energy of a non-expulsion weld. Severe expulsion may cause some of the problems shown on the slides later. Why we have such a high percentage of expulsion welds on automobile assembly line? A stuck weld or missing weld does not produce expulsion. A good weld also does not produce expulsion. Since conventional weld controller cannot detect the existence of a weld, the weld schedule is set intentionally to produce expulsion. The expulsion is used as a weld indicator.
In the plant's body shop, they begin by putting together the front structure of the van. It's made up of the radiator support, 2 side rails, and clips on the front of those side rails for the bumper structure. Then they put this front structure onto the automated production line. Meanwhile, robots weld what's known as the ladder assembly. It's the backbone that supports the floor and sides of the van. It contains, among other things, the pockets that will hold the seats. Now the robots take the front end structure and the ladder assembly and weld them together.
Either too much heat or not enough heat could create welding problems, and the next few slides show what kind of problem could it cause. Because of the lack of quality assurance on welding, so most of the people just add on a lot more welds. Those welds are called overweld or redundant welds. Professor Thomas Eager of MIT said it best. So for this reason, a given assembly may contain 1,000 welds because 500 good welds are required. The next three slides is talk about the recalls and the complaints because of the bad weld. Is it possible to weld non-expulsion good weld? In theory, the expulsion can be easily avoided with a correct selection of current and weld time, thus produce a good weld. However, the problem is the best quality weld are always made with parameters just below the expulsion limit. With careful analytical study of the welding process, it is possible to design a weld controller that can weld good non-expulsion weld and at the same time inspecting the weld quality. This slide shows the cross-section of a good non-expulsion weld. Majority of the conventional weld controller are open loop system. It cannot effectively control the weld quality. Homa expulsion-free algorithm eliminates the expulsion weld and the inspected weld in real time. An expulsion-free weld controller and monitor was developed by me that eliminates expulsion weld and monitor the weld while it's still forming, using only the tip voltage to provide the negative feedback signal to close the feedback loop. Digitize the voltage signal of several test welds to establish a detailed model of the weld. Using the feedback voltage compared with the stored model to terminate the weld just before the expulsion. This slide shows the simplified schematics of expulsion-free weld controller and the monitor. How this expulsion-free algorithm works. When the weld starts, the controller using the model of the weld to calculate whether a weld will form if continued. If the weld will form, a bright white light made of LED is turned on. This light replaces the expulsion as a visual weld indicator. This LED weld indicator uses 1 to 2 joules of energy instead of the expulsion, which uses several thousand joules. The controller follows the feedback voltage in real time to calculate the exposure limit. Just before the exposure limit is reached, the weld is terminated and the white light turns off. If a good weld is placed, a green LED light turns on. If a bad weld is placed, a red LED light turns on. Contact information. If you're interested to see a demonstration or want more information, please contact us. Thank you.